Hello everyone. Today we are going to discuss about the addFirst method in our DoublyLinkedList. So the format is same. First we will do the coding exercise and then after that we will execute some use cases on whiteboard.
Fun at first value is t. So this is our method we need to implement. First and most important thing, always try to write this in start so you always save from the bugs. Okay, next, how to implement. First thing is how many edge cases are there. So there are only, I think so, one edge case. uh, Head is null or no element, and second, head is not null or z1 or more elements. So only I can see these two cases which we need to fix. So simplest thing, first I can add check. Okay, if head is equal to null, then we will see what we need to do else. So these two cases we will implement. So if head is null, what I want to do, I want directly, I will say okay, node, create a node, put the value and null, next node should be null and previous should be null. Or as you know, we already gave the default values in the implementation here, so I can remove these two. Then so in this case um, it will work. Now the next case is, for example, now I am going to add the second value. It means I already have some value. For example, I have value 1 or maybe 2. It's easy because add first method we always add in the start, so it will be easy to understand. So first we added 2, so now my head has a 2 value, and the node which contain value 2 and its previous and next are null. This time user give me value 1 in the add first. Head is saying okay, I'm not null. So in case you are not null, first we are sure we need to generate a new node. Okay, now this is our new node and I'm sure I need to some node. So I have this new node. Now we need to play with the kind of referencing. So first thing is this new node has no connection. So new node dot next node should be equal to head. So basically what I'm saying, okay, so we have a one already two no value 2 node and head is pointing to that. Now I created a new node which is 1, and now one's next node pointing to the head. So there is a one connection. Next I need to say okay, head now move back, not move back, to move to the first node, the new node. So now head is equal to node, which means now head is directly linked with the value 1 node, and then heads dot next node is currently have a value 2 node. Anything else? Yes, now we have a previous node. So basically what we need to do here, I need to say, so before that the value of 2, is there any possibility I can access that somehow by using this? So this node is a new node, and node dot next node is equal to now head is equal to node. So I can do by using maybe node dot next node. So basically node or head both are same currently, so I'm saying node dot next node, go to the node which is 2 now, take its previous node and put head there. So again First we added 2 and there is null and null. Then I added 1. Okay, so now we added 1 this. Then after that I'm saying okay, node dot next node. Now you have a head means 2, basically this one, and head now is next nodes is referring to this. Then I'm saying okay, head, now you are a node, so basically now head is this, and I can access the 2 by using from next node. Then I'm saying okay, next node this one dot next node, basically this 2 which go to do, take this previous node and assign this to head, which is 1. So this will be the implementation. Now we can check if we implement it properly. I will create list dot add first 2, then print list, then add 1. Now run. First time when I added only 2, print, yep, null and null. Then I added 1. So in this case what happened, it's saying okay, previous node of 1 is null, then the next node null, which makes sense. Then basically the 2 node which is before this, it's saying okay, my previous node is now connected with the 1 and 2 and my next node is null, and basically our head is this 1. How I know? Because head toString always called, we call first time heads toString, so this is a heads toString. Now the question is, can we improve this code? Yes, we can improve this code. So basically what we are looking for, every time I have a head, I need to move 1 back and I need to connect those values. Like I'm creating a node value, so this is our new node. What I need to do, basically every time what we do, we are saying in this case node dot next node equal to head. So basically this is a next node of a new node, I'm saying head. So in this case this will work. Yes, if it's the first time, this still work. Why? Because in this case value and the next node and previous node by default is null and head is null for now. So this there is no bug. Basically these two cases are managed by this. Then next thing is, in this case I'm saying new node is equal to head and new node is also equal to head. So we achieve this. Then this case is already managed here. We can check this, and then in this case it's pretty simple. This node and head basically both are now same. So if I say head dot next node dot previous node, both conditions are same, so I can move also this here, and now these all 4, 5, 6 lines can move towards these 2 lines. Run again, everything is still same. Like what happened? So try to understand, we created a new node, if it's null or not null. For example, it's first time, so it's null, we added null, and then head has a new node with this 2 null. Okay, then next time it comes to the 1, so I added a value, it's 1. Now head is a 2, so we added a 2 in a next node of 1, so this is a next node of 1. Then I assign to head, so now head is my 1. Then I'm saying okay, head, go to your next node. So basically it's saying this is your next node which is moving towards this 2, and take this 2 previous node which is this and assign to them head. So this is 1 and size plus plus. Now we can add some more values. Maybe I can add in start, so it will look easy, good to read. 4, 3, 2, 1, and then we will run. So now you can see 1 is my head, the previous node, and the 2 is my next node, second node, and this is the previous one, then this is the third node, and this is the last node, and this previous one.
Welcome back. So we can take a one use case in which client created a doubly linked list, and then after that it added add first 3, then again 2, and same for 1. So in this case, what will be the how things will work under the hood? Okay, so just you already saw in a code, we have a one internal reference which is called head. By default, it's pointing to null, and then we have a one field which is size, which is responsible to count number of elements. So now first time when the client is calling list.addFirst, what will happen in our code? First, we are going to create a node, and because it's a doubly linked list, it's a node, forward node or the next node and the previous node. Then we added a value 3. Then what we did in our code, we implemented in a different way, but the last and the most easiest way that which we implemented, or maybe not optimized but in less code, we created a head equal to, okay, I will maybe write here, head equal to node value head and line. So basically in Kotlin, the value is value, the next node and the previous node, by default they are null, but in this case I'm saying okay, you have a head. So in this case, head is currently null. So once I created a new node, so basically this is a new node, the value is 3, head in star is null, so this is a next node position basically, so it's null. Then I'm saying now assign this to the head. So now in this case we assign to this, so the head is no more null, and then we have this statement, head dot next node dot previous node equal to head. So in this case, basically head, I'm saying okay, head dot next node. So next node is null. So because we are using the Kotlin, and in question mark means if that is not null, then execute this remaining. Otherwise, this will not do anything. So in this case, this statement will not work. Like it's done, we will return or it's complete. So done. Then the next time, and plus here the most important part, size is now 1. So next time again we call this method. So in this case we have a new node which is 2. This is the new node. Then I'm saying okay, node, your next node should be head. So in this case what we are saying, this will be pointing to the head. So head is currently pointing to this, so the same node. Then I'm saying change the head to this new node. I hope until you are with me. Now in this case, head, this is head dot next node, which is this, is not null. Yes, go to this previous node. So now this is the previous node, and assign the head. So this is head. So now we have a complete doubly linked list. I hope this makes sense. Again, first time we have a head, then I added a new node, I put the value 2, and after that I'm saying okay, your new node, your next node should be referred to the or linked with the head, and which is this. Then move the head. So we give this new node to the head. Now head referring to this. Then after that because we want to complete the link. In case of a single linked list, it's always like this, but in a doubly linked list, we need to make sure things should work in this way. So what we did and how I figure it out this. So I come on a whiteboard when I'm not recording this video, and I created this, and I'm struggling like how to make this link, and I put the same knowledge. Okay, head dot next node should go to this, and then from here I will take the previous node, and then I need to put the previous node equal to head, and when I wrote this, it started working. The last we can take one more example. Now this is 1. Okay, so in this case basically value 1, new node is created, 1 is this. Now I need to put head to its next node. Now I need to remove head from this 2 to this new node according to this head assignment. Now what's next? I'm saying, okay, if the next node is not null, so if this next node is not null, so basically I can access the next node, and then I'm saying, okay, go on the next node, take this its previous node, and then assign back to the head. So by doing this, you can see easily we have a proper doubly linked list, and we can see this structure, kind of a loop. So next node, previous node, next node, previous node. So that is our addFirst, and at this point we have now size equal to 3. Now if we discuss the time complexity of this method, so every time when we add, if you see, it's a constant operation. We created a new node, and then after that we are moving or swapping some heads or assigning some head like the pointers or the references. So basically it's a big O of 1. It's an independent from the input. Like if I add thousands of nodes by using addFirst, so addFirst is always a constant because it's always add the one new node and do this. So that is independent from n, so we can say it's a big O of 1 from the time perspective. From the space perspective, we are creating a new node, and it's always 1, and which is again the one value have 1. So I'm not sure how to explain that. Is it big O of 1 or big O of size of n? Like it's again the same, this constant, because we created a one node and we added that. So yep, for this video I think that is enough. So I hope I shared with you something new. See you in the next video. Bye.